So in today's lecture we shall learn how to find the open set in the following metric space. Metric space goes like this: if we have R, set of real numbers, with D1 metric, we shall try to find an open set in this space. How to find an open set? Let us learn that thing today. So what is D1? Let us define D1 first. So D1 is a metric. This is R2 space. D1 is a metric from R2 cross R2 to R plus, and it is defined like this. Let's take any vector from this D1 from x to y, where x is like this, x1 x2, and our y is y1 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 and y2. So D1 is a metric from R2 cross R2 to R plus, and x is this vector which belongs to R2, and y is equal to y1 y2 which belongs to this R2. So what is the definition of D1 xy? That goes like this. That is modulus of x1 minus y1 plus x2 minus y2. This is the definition of D1. So in this video we shall try to find the open set of this, how to find the open set in this kind of metric space. So let's try to find this open set B 0, 1, but this is open. We have to find this open set with respect to D1 metric and in this R2 space, R2 D1 space. So what is the definition of this? This is a zero vector. That means we can define open set to be the set of all those vectors x such that distance 1 D1 from x to 0 must be less than 1. Similarly, you can find other open sets in this, but this is one such example. I want to say that I'm trying to show how we will find open sets in this. This is one of the kind of open set in this. So what is the definition of this here? Therefore I can write D1 of x is x1 x2 and 0 is 0, 0, which must be less than 1. And what is the definition of this? Definition goes like this: that this is x1, this is y1, this is x2, this is y2. That means we can write x1 minus 0 plus x2 minus 0, which must be less than 1 by the definition of metric, D1 metric. That is x1 plus x2 modulus less than 1. Now let's try to find the graph of this. The graph of this is the graph of this is the this goes like this. That is, if x1 is positive, and x2 is positive, then this will represent x1 plus x2 less than 1. That means it is a kind of straight line. Okay, you can go. This is a kind of straight line which touches x-axis at this and y-axis at this. That means like this. And if x1 is positive and x2 is negative, then it will become x1 minus plus x2 divided by minus 1 less than 1, and geometrically it represents this. above this. And if x1 is negative, x2 is positive, then we will get x1 divided by minus 1 plus x2, which is less than 1, and it represents a region above this line. Similarly, third case is if both are negative, then if x1 is this is this, and for this we have both x1 negative, x2 negative, so as a whole we can say that this interior of this square, this interior without this boundary, represents this open set. So BD1 0, 1 represents this open set, BD1 0, 1. So this is the set of all those vectors whose distance d1 distance from 0 is less than 1, and geometrically we have seen that we have observed that this open set lies here. That means a kind of square here, but only interior, not boundary. Okay, thank you.